I've been putting off talking about classes as long as possible. The reason I put it off is because in my experience, when we talk about classes, we talk about how to solve a programming challenge on a more conceptual level, and it requires a shift in thinking, and it takes time to really understand the significance of that shift. Frankly, it took me years to really understand the implication of classes and, moreover, to understand the purpose and the value and just the thought process behind object-oriented programming and how it impacts the way that I build applications. So don't feel bad if you don't really get this the first time through it. Just keep working through the examples over the next few lessons, and you're going to start seeing the world around you as objects that have responsibilities, objects that are encapsulated, they have some public things that they can do, and they have some private implementations of things, okay? Objects that work together as communities to solve problems. Objects that can inherit from other objects and add additional functionality, but still be associated with a parent object, so some sort of inheritance idea, right? And objects that can be used interchangeably in place of each other so that you have a more flexible software system. We'll get to all those ideas and all those concepts throughout this lesson, but mostly when we get to the series on object-oriented programming in our curriculum. Okay. So up until now, we've looked at the world in what's known as a procedural style. This is an old style of programming where you work in terms of data in, data out. You use a lot of arrays and variables to represent data points. All right, these data points are loosely coupled, maybe by some naming convention, but essentially we're not thinking of them as a real thing. We're just thinking of them as just purely data, collections of data, okay? Beyond the logic, we're not really thinking about the maintainability of the code. In other words, we're not thinking ahead of how change will affect our code. Change in the form of new requirements, change in the form of new technology that comes out that we want to implement or utilize, and so on. We're not really worried about reusability, the possibility that we could reuse code that we wrote in one project in a second and third and subsequent project. We're not really thinking about composability. In other words, thinking in terms of objects that interact with each other that we can pull and use. This object needs to talk to this object, needs to talk to this object to accomplish this, okay? In order to build increasingly complex applications. And so as we move past the absolute basics, we're going to need to think about the code that we write at a higher level, to think about the conceptual relationships of the code that we write, of the objects that we create, to which we delegate some responsibility in the system. Okay, enough introduction, enough high-level overview. Let's talk about, in a tangible way, what classes really are and why they're so important. Virtually everything in C#, in the .NET framework, including the part of the .NET framework that deals with ASP.NET functionality, either is a class or it's part of a class. I mean, we've been working with ASP.NET Web Forms, and we created, in every application we built so far, a default.aspx page. Did you realize that what we were really doing was creating a definition for a class? And when we create that definition of a class, the ASP.NET runtime will create an instance of our default class whenever the user requests it from over the internet. And then once it creates an instance of that class, it'll begin calling methods on the class or setting properties or retrieving properties of that class. And ultimately, the responsibility that's delegated to that class is to generate HTML that represents a web page called default, okay? So we've been using it all over the place, even if we didn't realize it. The purpose of this and the next few lessons is simply to, first of all, understand what a class really is, and then secondly, recognize that classes are literally all around us whenever we're working in C#. All right, so let's talk about building our first class. Suppose that I wanted to create an application that works with cars or deals with cars. I may have a car lot, and I need to keep an inventory of all the cars that are for sale on my car lot. I want to keep related information about a single car in one container. So I might want to create a class that represents a car on our car lot. So what I want to do is look at my project CS-ASP_036. There's not a lot here, but you can go ahead and download and open it up and get to where I'm at right now. And what I want to do is position my mouse cursor at the end of the default class and before the closing curly brace of the namespace. So I want to put my new class right here between the opening and closing curly braces of the namespace, but outside of this class area right here between lines 10 and 16. All right, so I'm going to go to about line number 18 and I'm just going to create a new class called car. Simple as that. All right, so first of all, the keyword class tells the compiler what type of code block we're attempting to create. And so we're giving this code block, this class code block, a name called car. And we're going to see how this is used in a later step. So before I said that a method is a named block of code, well, in all reality, many blocks of code have names. And we're just creating another type of code block, and it has a name as well. We'll see how we can call that name in order to utilize the code block. All right, that's one way of thinking about it, but we're gonna graduate beyond that thought process here pretty quickly. So what we define between that opening and closing curly brace beneath class car will be the members of this class, including properties and methods. Now, classes can contain other kinds of members too, but properties and methods are the most popular and the ones we're going to focus on for the majority of this series. Now, you're going to learn more like events, another type of member of a class, but we won't do that for some time. So in this lesson, what I want to do is create 4 properties of a class: the make, the model, the year, and the color. These will be attributes of the class. A property defines an attribute of a class. And then whenever we create a new instance of the class, like we'll talk about in just a moment, we can retrieve those attributes in code, or we can set those attributes in code like we'll do in just a moment. All right, in addition to properties, classes can contain methods. And we already know what methods are, at least on some level, right? We call them a name block of code that you can call. And just to kind of extend that analogy or that definition a little bit, not only are they a name block of code that we can call, but they typically represent something the class can do, a task it can perform. So we created helper methods in the previous lessons to do something meaningful, like perform some formatting, an output to the screen, maybe to keep track of a given character and his health and how much damage he does to another character in our little games and so on, okay? In our car class, there's a lot of different ways that we could go with this, like what we expect the car to do. For example, we could create a method for the car to accelerate and the car to decelerate. And that might make sense if we were building an application that, for example, modeled traffic patterns. But accelerate and decelerate, things that the car class can do in the real world, don't really make sense for our particular application. So in that respect, we're talking about an abstraction that makes sense for our specific application that we're building. We're not trying to model everything about a car. We're only interested in modeling or creating properties and methods that are useful for the type of application we're building. So in our case, we might have a method called determine market value, which would be more appropriate for an application that keeps track of the value of cars on our car lot. Okay. So what we're going to do is to add some properties. We already said we were going to add make, model, year, and color, and we're going to take a very simple approach to creating those properties. And this little technique that I'm going to show you combines code snippets, which we're already familiar with a feature of C# called auto-implemented properties. So we're looking at the easiest, simplest form of properties. However, there are several different ways to create properties, and they're more elaborate, and they help us to accomplish an idea inside of the greater world of object-oriented programming called encapsulation. But let's just hold off on that and create the simplest kind of properties called auto-implemented properties. And to do this, what we're going to do is use the prop. Let's start. Put our mouse cursor there. Prop. And notice when I type that keyword, IntelliSense says that this is a code snippet for an automatically implemented property. So I'm going to hit Tab on my keyboard, and it creates the rest of that line of code for me. And just like code snippets in the past, I can use the Tab key to move back and forth between the two parts of the auto-implemented property. So a property is going to be sort of like a variable, all right? It's going to have a data type and then a moniker, a name that we're going to give it. So in this case, we need to create a string property called the make of the car, and the make will be something like Toyota or BMW or Oldsmobile. All right, and once I've finished typing out those two words, I'm just going to hit enter on my keyboard once to move to the very end of that line of code, and then enter again in order to move to the next line of code. So I can type in a bunch of properties very quickly. Prop tab, string tab, model, enter, prop, tab, int, year, enter, prop tab, string tab, color, enter. All right, so now I've created 4 attributes of the car class that will keep track of a single instance, a single car's make, model, year, and color. Okay, so undoubtedly, if we were to have 2 cars on our car lot, we would need 2 instances of the car class to kind of hold on to these values, the year, the make, model, year, and color. My car happens to be the one I drove in this morning, at least, is a Ford Escape 2008 white. Your car might be a BMW 750 Li 2014 black, and if that's your car, then you don't need to be watching this video. You're probably already pretty successful. Okay, so again, we're creating an application that will keep track of the inventory of all the cars on our car lot. Now, as a developer, I need to collect some information about each new car that we take possession of and that we put on our car lot for sale. Now, to make this a real application, I might need to create a graphical user interface to collect information about each new car from a user. In this case, the user might be somebody who goes out to the auctions and buys the used cars, or might be somebody who has made an order from the dealer or from the original manufacturer, and now that shipment has come in on a truck, and we need to enter all that information so that we have that in our database of cars that we're offering on our car lot, all right? And that user interface could be in the form of a web page, a Windows application, a Windows Phone application, or something that we could use on a tablet, whatever the case might be. But in our particular case, just to keep this really simple, we're just going to create new instances of the car class in our page load event. All right, and we will flesh this out later in order to to allow users to type in all this information. At which point we would probably want to persist or store each instance of a car in a file or a database, and that's a little bit down the road from where we're at right now. Okay. So to begin this process, let's say that we have a new car come onto our car lot, and I'm just going to hard code this. Again, keeping in mind that in the future I would probably allow an end user to type this information in. But I'm going to create a new car called my new car, and I'm going to set that equal to a new instance of the car class, like so. Okay? So an instance of a class is known as an object. All right, an object is not a class, and a class is not an object, even though you'll sometimes hear people confuse those terms. I do it all the time, all right? But Think of the class as a blueprint, and an object is instantiated from the blueprint, or rather, it's created from a pattern. And once we've created it from a pattern, it's in the computer's memory, and we can manipulate that object just like any variable in the computer's memory. So in the real world, in the meat space, I guess you can say, you can use the same blueprint to create many new houses in a neighborhood. You use the blueprint once, it takes 3 months to build a house. You use the same blueprint a second time to create the house next door. A couple of months later, you use the same blueprint to create another house next door to that. 3 different implementations or instantiations of the class. There's one house object number 2, and house object number 3. They're at different addresses, but they're all from the same class or the same blueprint, okay? Or you can think of this in terms of a pattern for like creating clothing. You create a new instance of clothing that can be sold to a different customer. Or you can think of this in terms of a recipe that's used by a chef, all right? The new instance of the recipe can be offered during one meal to one customer or during another meal to a different customer. The same is true with classes. Each time you create a new instance of the class, you have a new object that is distinct and separate from other instances of that class. So another way to think about a class is that it's like a cookie cutter. Okay, you can't eat the cookie cutter. It's made out of metal and it has a shape. All right, but you can eat the cookies that are made with the cookie cutter. So when you instantiate a class, you create a cookie, the instance, based on the shape of the cutter, the class. So think of this new keyword here that we've used several times up until now, but we've never really talked about. That new keyword is like a factory, all right? It uses a blueprint or a pattern or a recipe or a cookie cutter, any of those analogies work, to create a new instance of that blueprint pattern, that cookie cutter, whatever the case might be. Or rather, it creates a new instance of the class. It brings the class to life in the computer's memory and makes it usable. So you can create many new instances of the class. In other words, you can make many new objects, all based on the same class, but each one is distinct from the others, if for no other reason that they're different implementations in the computer's memory, okay? Or rather, like different variables, I guess you could say. They live at different addresses in the computer's memory. You have different handles to each of those buckets in the computer's memory, all right? So in that sense, what we're really doing here is defining a data type. We're defining a data type that's similar to string or int or double, but we're just creating it and calling it car. And it has different properties and methods than the int and the string and the double and the bool and all those simple data types that we've been using up until now. All right, so what I'm going to do now that I've created a new instance of the car in the computer's memory, what I want to do is set the properties of this new instance of car called myNewCar to their appropriate values. Now in this case, I'm just going to hard code the values again. In a real application, I would present a user interface to an end user, and they would type all this information out, hit save, and we would create a new instance of a class and then save those values in that instance of the class. All right, but we're not going to do all that just yet. We'll do that later. So as I type out this example, notice that when we use, for example, myNewCar dot, all right, so we use the dot operator, it pops open IntelliSense to show me the members of that class that are available. So in this case, we see that there are 4 properties. There are the color, the make, the model, and the year. There's also a few other properties like toString, getType, getHash, equals. What are those? Well, we'll talk about that later, but in essence, every time you create a new object, in fact, every object in the .NET Framework class library, every object, or rather every class that has anything to do with the .NET runtime, the .NET Framework, whatever the case might be, all inherits from a single type called system.object. And system.object has some very baseline functionality. And so we get these features, these properties for free because we created a new class. We'll talk about inheritance later. But for now, let's just focus on the properties. So for example, I want to set a new make. We'll call this Oldsmobile. And we'll do mynewcar.model equals Cutlass Supreme. mynewcar.year equals 1986. And mynewcar.color equals silver. Okay. So let's take a moment to dissect this code and really understand what's going on here. First, I use the name of the instance of the car class. We called this mynewcar. You can think of this as the handle to the bucket in the computer's memory that's big enough to contain an instance of the car class. And we use that handle, that moniker, to access each of the properties of the car that I'm going to set in this case. So I use the equal sign as the assignment operator. I'm assigning a new value to each of the properties. These new values for each property are maintained in memory for this instance of the car class. And as long as I have a reference to that instance of the car class, I can retrieve the values in those properties, or I can change them again if I want to. So once I have a new instance of my car class and I've set its properties, I can do some useful things with this instance of the car that I've named mynewcar. For one thing, it's a nice kind of collection, I guess you can say, of all the related properties that define one car on my car lot in a nice little container, so I can just use mynewcar now, and we know, oh yeah, that car is the Cutlass Supreme, the 1986, the silver one over there on the car lot. Okay, so what I can do now is not only set those properties, but then I can also retrieve those properties. All right, so I'll do this. Result label.text equals string.format. And then we'll just do, the string replacement characters like we've done so many times up to now. And what we'll replace are the various properties of our car. So in this case, in order to retrieve or get the values for that instance of the mynewcar class in memory, I'm going to do this. So mynewcar.make, mynewcar.model, mynewcar.year, and I'll just do a toString on that, and then mynewcar.color, like so. Okay, so to make a very important distinction here, in these lines of code, I'm setting the properties. In this line of code, I'm getting those properties or the values of those properties. And as you might expect, when we run the application, it'll merely print them out in a very unexciting way. What's more important than that is the basics of working with a new instance of a class and setting and getting properties, okay? And now let's move on, and what I want to do is create a helper method that we're going to call from the page load event. And what this method will do is allow us to pass an instance of the car class, and then inside of that helper method we'll do something like print out some value to screen. So here's what I'm going to do. I'm going to create a private double determine market value, and what I'm going to do is an input parameter. I could use string or integer, but what I'm interested in doing is passing in an instance of car. And since the car class is a data type, almost just like string and integer, I can do this, car, like so. All right, now this is where things get a little tricky. Capital C car is the name of my class. Lowercase c car is the input parameter name. It's like a variable name. So now I can reference instance of the car class that we pass into our helper method by using the variable name car within the body of this helper method. Okay? So yes, C# is case sensitive, and so capital C car is different than lowercase c car. That's kind of hard to get through your mind on the first couple of times, but it'll become second nature. And since it's a car, I wanted to name it something that would remind me, what am I working with here? So in this particular case, what I want to do is write some algorithm, some complex algorithm. Maybe even it goes out to the internet. It looks at the Kelley Blue Book value. It looks at the condition of the car. It determines the value. But I'm not going to go through all that business. What I'm going to do is just something super, super simple here. And I'm going to paste in some code I've already written, like so. All right. So this is a very unexciting example. Here we've basically created a double called car value. We've set the value to 100. And then I got some code comments that someday I'm going to write this and make it really elaborate and cool, and it'll figure out the value of a car. But for now, we're just going to hard code it and return back the car's value. All right. But the key idea here is that you can use that car class as a data type anywhere that you would typically use data types in your code, as we've learned up until now. So let's suppose, for example, that we wanted to actually work with the determined market value. The way that I would do this is called the double market value of car equals determined market value, and I'm going to pass in my new car, like so. And then I can just tack this on to the very end here. We'll go 4, and we'll actually make this currency, and we'll go over here all the way to the end and say market value of car, like so. And now let's see what we come back with. Okay, again, not very inspiring. Let's change this up a little bit. At this point, we haven't used the car variable, so let's expand this example out just a little bit. Okay, so this time around, what we're doing is we're using the car object, we're retrieving the year, and if the year is greater than 1990, then the car value is $10,000. If the car value is less than 1990, then the car is only worth $2,000. All right, so now let's run the application again. And this is only slightly more interesting, but the key idea here again is that we can reference the attributes, the properties of car, of our instance of the car class. We can pass in an instance of car and then use that instance inside of our helper methods. Let's take this one step further. Instead of making this a helper method in my default class, let's just take this whole definition here, and I'm going to put it inside of the car class instead, like so. And I'm going to make this a public instead of a private for reasons I'll explain later. I'm going to change the lowercase d to a capital D because I want to follow a naming convention. All right, and instead of using the word or even passing in the car as an input parameter, I want to show you that I can reference this instance of the car class, its year property, okay? And this is actually superfluous. We don't need this keyword. This would work just fine. In other words, we can access my new car's year just like so by just using it. But this keyword I prefer because it helps somebody else reading my code, or maybe it helps me later on to understand that this property was defined earlier in my class. All right, we'll get into all that stuff later on. But let's change now how we're calling. You can see that we're getting a red squiggly here. And this is an easy fix. We're just going to copy this line of code. And instead of calling it this way, we're going to say my new car dot determine market value, like so. Okay? Now let's go ahead and save it and run it, and we'll get the same results, but the way that we went about this is dramatically different. Okay, so this was our first step towards understanding object-oriented programming. A very simple, concrete example, that of a car. A car is easy to conceptualize. We've all had cars, been in cars. It's tangible and it has a real-world equivalent. Now, as you begin to build applications, especially in this series of lessons, you will not always be responsible for creating your own custom classes. You're going to be using classes from the .NET Framework Class Library like we've done several times up until now. And I believe that at first that's going to be your main exposure to classes. It'll be those classes that were created by Microsoft in the Framework Class Library, the base class library, and I'll explain what that is in a lesson or two from now. In most cases, the kind of classes that have been defined in the .NET Framework base class library do not have real-world equivalents. In other words, they're more conceptual in nature. For example, I may work with a class that represents a connection to the internet, or I might create an instance of a class that represents a stream of data, which is sort of like a pipeline of data flowing from one place to another. Or I might work with like a span of time, a time span object, all right? That's a conceptual idea. There's no real world tangible implementation of a time span that we can touch and hold like we can a car. So in these cases, we're not working with something tangible in the physical world. And so that can cause a little bit of confusion when you're beginning to see the world, not just the physical world in terms of objects and classes, but also the conceptual world in terms of objects and classes, all right? And as you mature as a software developer, you might want to invest more time learning how to create your own library of classes that interact with each other as a means of breaking down real-world problems into code. And again, this is a process called object-oriented analysis and design and programming, and we're going to cover that topic in that series, in our curriculum, a little bit later on if you choose to go that route. However, to be honest with you, if you're just going to go down the path that you see here on the left-hand side, I think it's the blue path, the tools-driven approach to building applications, you don't need to know everything there is to know about object-oriented programming. We're going to cover enough in this series to get you on your feet and to be able to build simple applications, all right? But over time, you're going to want to invest more time understanding object-oriented programming for all the benefits that I mentioned at the very outset. So to recap this lesson, a class is a data type in .NET, similar to those data types that you've been using, like string and integer and so on. You can define a custom class with properties and methods, and then create instances of those classes, or rather create an object by using the new operator. And we said the new operator is like a factory. It's what's responsible for creating an instance of that object in the computer's memory and returning back to you an address that you can hold on to, and whenever you need to work with that object in the computer's memory, you just use that address, that moniker like my new car, to access it and to access its properties and methods. And you can access that object's properties and methods by using the dot operator, the member access operator for a class, okay, or an object rather. There's still a whole lot more to say about classes, so we're going to pick this up in the next lesson, the next several lessons. Just hang in there if this was a little bit weird or too conceptual for you, and you're like, what's the point? I don't get it. It's just easier to work with variables. Trust me, while it seems that way at first, in the long run, the more investment you make in understanding classes, the better off you're going to be as a software developer. In fact, I'm not even sure you can get a job as a software developer if you don't really understand classes, at least in the .NET world, okay? So you got to get this, and you can. It just might take a little bit of time to really digest what they are. All right, that's enough encouragement. We'll see you in the next lesson. Thank you.